Hi everyone. In this video, we are going to talk about how pointers work with functions, specifically the concepts of call by value, call by address, and call by reference. Let's start by reviewing something we mentioned earlier about functions. When we define a function, we can specify what type of data it accepts as parameters. Okay? This basic way of passing values into a function is called call by value. That means when we call a function, the program creates a copy of the data and passes it into the function. So the function works with a copy, not the original data. Let's take a look at this example. Suppose we define a function that doesn't return anything, and inside it, we increment the values of parameters a and b. And then back in the main function, we define two variables, x and y, and pass them into the function. And after that, we print out the result. Okay, let's see what will happen. You will notice the values haven't changed. Just as we explained earlier, that's because the function only works with copies of the variables. So now the question is, what if we want a function to modify multiple variables? Can we just change the return type and then return multiple values? The answer is no. In C programming language, a function can't return more than one value directly. So how do we deal with that? This is where pointers come in handy. We can define the function to accept pointer parameters, and these pointers will point to the memory addresses of the variables we want to modify. That way, when the function runs, it can directly change the values stored in the original memory locations. Let's update this example using pointers. Okay, in the function definition, we change the parameters to pointer type. And at the call side, the main function, we need to be careful. Since the parameters are pointers, we must pass the addresses of the variables using the address of operator. Okay, in the function body, since the parameters are pointers, we need to use the dereference operator to access or modify the actual values. Don't forget to add parentheses around the dereferencing and the parameter. Otherwise, the result might be different. We will explain that more clearly when we get to arrays. Okay, let's run it again. As you can see, this time the value do change. This technique is called call by address. So what is call by reference? It is a way to pass arguments, so the function refers directly to the original memory location, just like call by address. But here's the key difference. With call by address or call by value, we use pointers or copies, which themselves require memory space. Call by reference doesn't need that. It accesses the variables directly without needing a separate memory allocation for a pointer or a copy. If you are not clear on the underlying mechanism, that's okay. Just remember, call by reference is more memory efficient in most cases. To do call by reference, we change the function parameter types to reference types using the address of operator. Okay, and since we are directly referencing the variables, so we don't need to use the dereference operator. It behaves just like working with normal variables. Okay, also, back in main function, we don't need to use the address of operator anymore. the function already knows how to access the original values. The result is sent us with call by address. You might be wondering if call by reference is simpler and uses less memory, why not always use it instead of pointers? That's a good question. And the answer lies in dynamic memory allocation. When we start talking about dynamic allocation, you will see there are situations where using pointers is necessary for certain designs. Alright, in this video we covered call by value, call by address, and call by reference. In the next video, we will introduce another commonly used data container. See you then.